Hello, Chi community. I'm Carl C. Haynes, and my advisor is Barbara J. Ericson. We're from the University of Michigan School of Information. Today, I will talk about our paper, Problem-Solving Efficiency and Cognitive Load for Adaptive Parsons Problems versus Writing the Equivalent Code. Introductory computing courses have a high dropout and failure rate and low diversity. Students drop out because they find learning to program frustrating and difficult. Underrepresented groups in computing are more at risk because they often have less prior programming experience. Students need a great deal of practice to acquire and retain programming knowledge. Most introductory computer programming practice requires students to write code from scratch, taking an unpredictable amount of time, and students often get stuck. We believe adaptive programming practice can reduce students' frustration, improve diversity, and provide students with effective and efficient practice. But what is adaptive programming practice? It's practice that adapts based on a student's performance. It keeps the student challenged but not frustrated. Adaptive Parsons problems are a type of adaptive practice. These problems require learners to place mixed-up code blocks in the correct order and can include distractor blocks not needed in the correct solution. Cognitive load theory predicts that Parsons problems should demand less cognitive load than requiring students to write code from scratch because they are a completion problem rather than a whole task problem. In an adaptive Parsons problem, if the student is struggling to solve it, it can be made easier by removing a distractor, providing indentation, or combining blocks. In our system, this adaptation is triggered by clicking on the Help Me button. In contrast, write code problems, often viewed as more authentic, require programmers to create programs from scratch without any scaffolding other than unit tests to check the results. What is the effect on efficiency of solving each problem type, and what is the effect on cognitive load? To answer these questions, we conducted a within-subject study in an undergraduate data-oriented programming course on Python during the winter semester of 2020. We also investigated students' attitudes about each problem type and their thought process when solving them. We conducted think-aloud observations with students in the same course to answer this question. And finally, we explored whether students understood and valued the adaptation through an end-of-course student survey. We created two different sets of problems, A and B, that were equivalent. The problem types in each set alternated between Parsons and write code problems. We collected log file data of students' interactions with each set of problems, ran Mann-Whitney U and pair t-tests, and calculated effect sizes. Participants were significantly faster at solving 4 of the 5 Parsons problems than the write code equivalent. Problem 1, has 22, was not significantly faster to solve as a Parsons problem. The given solution was unusual, and our findings support this claim. Please see the paper for more information. The mean self-reported cognitive load rating for each Parsons problem was lower than that of each equivalent write code problem, though the difference was significant only for 2 problems. However, students in the think-aloud observations all reported that Parsons problems were easier to solve than writing the equivalent code. This implies we need to find a more effective way to determine cognitive load and validate student perceptions. Some students clearly value Parsons problems since they provide structure and help you solve the problem. In contrast, some reported it was easy to get stuck while solving write code problems. Some students were confused by the intra-problem adaptation that provided indentation and didn't find it useful when 2 blocks were combined that were already together. We have since modified the adaptation to no longer provide indentation, and we're working on the algorithm to combine blocks. 2 students who expressed a strong dislike of Parsons problems had prior programming experience. They claimed to learn more from write code problems and that Parsons problems were not beneficial. Another student liked that they had more freedom when writing code. Finally, we conducted an end-of-course survey to determine the prevalence of students' attitudes. While some students in the think-aloud study reported hating Parsons problems and preferred to write code from scratch, we found only 30.4% of students would rather write code from scratch. Most students, 80.6%, reported finding the adaptation triggered by the Help Me button useful. However, 17.5% reported not understanding what happened during the adaptation process, which means it can be improved. Our key takeaways are that adaptive Parsons problems are usually more efficient and require less cognitive load. Prior programming experience mediates students' perceptions of adaptive Parsons problems, and improving adaptive programming practice is an iterative design process.